All right, hello everybody. Thank you for joining us on this Friday afternoon. This is a first for MeCAD. Let me just start my video here. Let me just share my screen with you for a second. There we go. So, thank you for joining us again on this Friday afternoon. This is a first for MeCAD to have a webinar. We thought, why not do this now and really engage with you guys in a different way. Just some guidelines first up. Because of the number of people in the group, could I just ask all of you to turn your videos off, and we are going to mute everybody, and we will open up the chat. At the bottom of the screen you will see a small chat window. Please go ahead and ask questions, and we will get to questions and answers at the end of the session today. So we are going to be recording the session today, so you don't have to worry about trying to capture everything or take notes. We will record the entire event, and we will give you the video after the session today. We're also going to be providing you guys with a PDF of the PowerPoint presentation that we will be presenting today as well. So I'm not going to spend too much time talking. I just wanted to really have a shout out to all of our customers, and thank you guys for joining us and really connecting with us. You know, we as MeCAD Systems know that it is a difficult time, and it's a unique time where we all are facing different kinds of challenges, both in our personal lives and in our business lives, and we are really wanting to stay connected with you. So we will be communicating with you shortly about certain promotions that we are having, price locking. You know, the rand dollar is going crazy at the moment. We really want to encourage you guys to connect with us, and we are very willing to help and work with you as companies, whatever it may be. So please stay connected. I want to just encourage you guys to, while you are spending time at home and being online, we have our website at mecad.co.za, and we're going to be updating this now over the next few days. Every few days we'll be adding new content to our website. We're going to be hosting more of these sessions on Zoom, tips and tricks sessions, different seminars on simulation, Composer, and PDM. As you guys give us feedback, we will host more of these events. Please, if you could also subscribe to our YouTube page as well. We will send you the links to this, but we are going to be uploading videos to our YouTube channel. And if you subscribe to our YouTube channel, as soon as we do upload videos, these will become available to you. As well as our Facebook page and our LinkedIn page. You know, connect with us, join our social media platforms. And as soon as our team publishes information and content, you will be the first to know about it. So enjoy the session today. I'm going to hand over to Rudolf and Joshua. So Rudolf joined me in Nashville this year to collect his award as South Africa's first elite application engineer. So we're really proud to have Rudolf in our team, and he's going to be hosting the first session, the first bit of the session this afternoon, the next hour. And Josh, one of our engineers from the Centurion office, will also be handling the second part of the session today. So I'm going to be handing over the reins to Rudolf now, and enjoy the session, everybody. And yeah, please be patient with us as we're using this new technology. The things are new for us as well. So let me give this over to Rudolf. Just give me a second while I find his name in this mass of people. Luckily, it's alphabetical. And I'm wearing my glasses. Right, Rudolf, you are now the host. I'm handing over to you.
There we go. All right. can, awesome. Just want to check, is everything up and running? Okay, perfect. Thank you. As just to add on what Quentin said, thank you guys for joining us today for this tips and tricks session. Really glad that you guys can join us. Just a bit of agenda for today. So I'll be going through the basic using SolidWorks and getting around SolidWorks, and then I'm going to jump right into sketching as well. Josh will handle the second part, which is the parts and assemblies side of it. Okay. Okay, so let's just jump straight into it. So our first one is the repeat the last command. That's the enter key on your keyboard. So if you quickly want to repeat a command, you can simply press enter on your keyboard. So let me quickly demonstrate this for you with this revolve feature. Okay. So I'm just going to edit the sketch quickly just to show you guys. All right. So if I go ahead and use my smart dimension, and I'm going to dimension this entity here, 100. Okay. Now you will see I'm out of my smart dimension. By simply pressing enter on your keyboard, you will jump right back to your smart dimension tool. This is useful. Then you don't have to go all the way back to smart dimension to actually go and create the dimension. I'm going to show you again. Just by pressing enter, you can simply go and dimension that part. All right, and this is not just for sketching, it's in the part environment as well, so for features. So what I can do for this sketch, I want to go and create a split line. So I'm going to take this entity and create a split line on that face. So you'll see if I go under my features, I go to curve split line, I select this sketch here, select this face, I click OK. There's my split line created. So without going back to my split line feature, I just simply press enter on my keyboard, jumps right back to the split feature. Click that sketch, choose that face, and I can click OK to accept that. All right, so quite simple to go switch between, go back to the last command. Okay. Next up is the reference plane. So the reference plane is quite simple, but there's a few, I want to call it shortcuts that we can use for that. So the first one is the control drag option. It's really useful. And then also the pre-selected two parallel faces to create the mid plane. Okay, so let me demonstrate that for you guys as well. So the first one is the right plane. So I'm going to use the right plane. And from the right plane, I'm going to hold in control, select the corner of the right plane, and just simply drag that plane out. That will create an offset plane for me. You can simply put in the offset and accept that. Really simple. Okay. The other one that I wanted to show you was the mid face. So if I go and select two parallel faces, for instance, that one there, and then that one there, and I go reference geometry plane, then by default, SolidWorks will automatically choose mid plane for me. And I can click OK to accept that. Okay. All right, so I'm sure most of you have seen this before. It's the recent files on the welcome screen inside of SolidWorks. So I'm just going to go through this quickly just to show you what it is and what the capabilities is. So the shortcut for getting this recent files command is the R on your keyboard, the R key. Okay, let me show this. So if I press R on my keyboard, it will show you all my recent documents. So from here, you can simply drag and drop parts in if it's an assembly. You can go down and scroll through all your recent documents. You can use filters, then you can type in a specific name. If you, for instance, if I type in water, it will actually show me the water tank, so on. You can filter between, you can filter between assemblies, parts, and drawings. And then also the nice thing is you can pin down specific projects that you are working with. So you see, I've pinned down a few here. So to pin down a part, you simply click on that pin there. All right. So from in this recent document, you can actually, you'll see there's a drop down option there. So for assemblies, you've got the option to go and choose what mode you want to use for the assembly, and also the type of configuration. So you can open up the assembly from here. It's quite nice. Okay. So also remember that pin down, so you can pin down up to 100 files, which is quite nice. So those pin down projects, you will see it's listed here under as well. Under file, you open recent, all those pinned down is what I pinned down in my most of my recent documents as well. Yeah. The context menu. So this is quite useful if you are in an assembly environment and you want to mate two faces together, and the context menu pops up, and then suddenly it disappears. All right, I'm going to show you what happens. So we see with this time of when we work from home, there's a lot of distractions and so on. So let me just show you. If I multi-select that face and that face, you see this is called my context menu. All right, so now I got distracted and I move away my mouse cursor. So how do I get that back? So simply go to that point where you last were and press Control, and then the context menu will appear again. There we go. As easy as that. The D key. All right, so the D key is to move the confirmation corner and breadcrumbs to your mouse pointer location. So you can use the D key to model without the feature tree. So it lists all the features and the sketches within your within SolidWorks. So I'm going to show you this cool assembly. So I'm pretty sure most of you are going to have a braille tonight. So I choose this braille for us. So let me show you. So if I choose a component, say for instance this component here, and I press D on my keyboard, you will see it shows you a full list of how this part was created. So you see it consists of the main assembly, subassembly, the part, the body, and then the feature. So within this D key command, I can actually go ahead and edit these features. I can edit the sketch. So you don't have to go in your feature manager design tree and go and edit that sketch. You can simply go on your screen in your graphics area and go and select those components within the assembly. So it's really useful. It just saves you some mouse time. The S key, I think this is the best shortcut, I think, from SolidWorks, is the four toolbars key. So S is a shortcut bar for sketches, parts, assemblies, and drawings. So how this works is, you'll see if I press S on my keyboard, and sorry, this is also fully customizable. So I'll show you now an example. So if I go here in this part again, and I press, so obviously if I press D here, I want to edit the sketch, and I press S on my keyboard, you'll see it shows you a full shortcut list of commands that's available for sketching. All right, so from here you can simply click the command you want to use. I'm going to show you again. Anywhere in the graphics area, just press S. It will show you a shortcut bar. And as I said, this works for parts, for assemblies, for drawings, and for sketches. So in my part environment, I press S. Now you've got these features available. So on that S, on that edge, I press S, and then you can use a fillet, for instance. All right. And like I said, this is fully customizable, so you can customize this S key toolbar. So to do that, you go here up at the top, you go to Tools, you go to Customize, and then under your Shortcuts bar. Okay, so you will see here's my 4 toolbars. Got one for parts, one for assemblies, one for drawings, and one for sketching. So for instance, the sketching one, I can drag and drop sketch tools that I often use. For instance, I want to use the ellipse one, then I can drag and drop the ellipse in here. If you want to remove some stuff, I can just chuck this away by removing it. All right, it's really quick and easy. Okay, next up is the selection tool. So I'm going to show you with an example how we use the previous select, the select other, and the shift select to select the transparent parts. Right, so let me open up the braille assembly again. Okay, so for this braille assembly, what I want to do is I want to go and do a previous select. So first of all, as I said, there's a lot of distractions working from home, and I'm busy with my braille now, and I want to go ahead and choose all of these components. For instance, so I choose all of them, multi-select them, and now the dog starts barking and I want to go out, and suddenly I lose my selection. What do I do now? So how do I go back to that selection? So you right click anywhere on the graphics area, you will notice there's a thing called previous select. If you click on that, it will remember the previous selection you did. This is quite nice. Just saves you that time. Okay. Next up is the select other. All right. So for instance, let's say I want to go and select this part, this tube here, that face of that tube, but I can't see it. It's behind these faces. All right. So what you can do is you right click anywhere in your graphics area, and you will see there's a select other option. Right. So now look at my mouse cursor. So the left click is just a selection click. The right click is to actually go and hide faces. So if I hover over that face and I right click, it will actually hide those faces. And now I can go ahead and click on that pipe, which I want to select, and now it's selected for me. So this is quite handy if you've got a big assembly that the parts is hidden away behind other parts. Okay. Sorry, I just want to go back to that one. I forgot one, yeah. And the other one is the shift select. All right, so for transparent parts like this, you'll notice that because it's transparent, sometimes I can't select that transparent face. So how do I select that transparent face? It's simple. You simply just click, holding shift, and now that transparent faces will be available to select. Easy. Right, this is also an easy one. I'm sure most of you used this before, but for those that didn't know about this, you have filters available inside of SolidWorks. So for easy control of your body spaces, edges, or axes. F6 is used to turn the filters on and off. You can use F5 to view the filter bar, and then you can dock those toolbars. And then also I'm going to show you the power select tool, the select by option. It's quite really useful. So let me go ahead and demonstrate this for you. So the filters, as I said, if I press F5 on my keyboard, my selection filters pops up. Now I can select the filter that I want to use. For instance, I want to filter only the edges. Now you can only select edges. Only select edges. All right. To turn off the filters, you press F5. Or to turn off the filters, you press F6, then it will turn the filters on and off. To remove the selection filter, you just press F5 and it will remove that. But I also just to pin it down here at the bottom. Right. Sorry, I forgot the one. Let me just move back here. The power select. Okay. So the power select is a tool that you can choose what to select by. So for instance, let's say I want to select all my toolbox components in my assembly. So I don't want to go and search for all the toolbox components. I want to have a simple click just to select all my toolbox components. So notice under my selection bar here, so next to rebuild, there's a drop down. All right, so click on that. Now you have the ability to select, volume select, select suppress, select hidden, select mated to identical, internal by size. So let's first choose the select identical components. Okay, so I'm going to select all the identical components of this screw here, and then it will highlight all that identical components, which is really useful. Then you can use that and you can suppress it or hide it, whatever you want to do with it. All right. Another one is I want to select all the toolbox components. So now it actually highlights all the toolbox components for me. See that? Saves you a lot of time to go here and shift select everything and do that, and then you perhaps miss one. So use that. And another one is the advanced select. This is quite useful. So you have a criteria that you can select by. So let's say, for instance, I want to look for all the components that the display is equal to it's transparent. So if I click apply, it will show me all the components that is transparent in my assembly. So you can choose a category for the mass, for the weight, for the material used, and so on. Please use this. This is really useful. Okay. Next one is the collapse tree. Okay, so this is also a nice one to have. So if you've got a big assembly, for instance, something like this, let me just wait for it to open up. This is a big assembly. Okay, so this assembly here. So I'm busy with my assembly now, and you'll see my feature manager design tree is like a whole list of different components here. So I don't want to go in here and collapse each one of them one by one. So what you can do to fully collapse the whole assembly just by using Shift C, you will collapse the whole assembly in one go. So just a bit of a tip for you guys. Okay, moving on. The normal to. So I'm pretty sure all of you know the normal to command. So if you click a face and you go normal to, you will go normal to the positive. If you click normal to again, you will again flip the normal. But did you guys know if you select a face first and then another face, the second face will be your up orientation. So let me demonstrate that. So I'm going to take the bri again, this component. So I'm going to use Shift C here. There we go. All right. So I'm going to look at this component. So as I said, normal to, select that face, normal to. We know what happens. If I click on that face again, I go normal to again. It just flips the normal, right? But let's say I want this face to be normal to, but I want this face to be my up orientation. So multi-select, holding control, select that face, select that face, and now you go normal to. There we go. So normal to, and that face is my up orientation. So it's quite useful to know this. All right, reference stride. So I'm sure a lot of you have seen this reference stride before, but what does it actually do? So the reference stride is used to change your view orientation. So let me demonstrate this. There's a few shortcuts around the triad. Okay, so if I look at my component here, my assembly, so my reference triad here at the bottom. So notice here, if I click on a specific axis, it will take me normal to that axis. Okay, I'm sure all of you know this, but let's say I want to rotate about a certain axis. So holding in Shift and clicking an axis will actually rotate the model 90 degrees, any direction, or any axis, I mean. Holding in Alt and choosing an axis will rotate it 15 degrees. Okay, combining the Shift and the Alt with Control would just reverse that direction. Okay, it's quite useful. Okay, just some out-of-the-box shortcuts that you guys might want to use. Obviously, Escape is to cancel a command. Control Z is to undo. We've already discussed the R key, which is my recent documents. Control Q is the force rebuild. Control B is to rebuild the feature since you last changed it. Control Tab is obviously to switch between open files. And then Control 1 up to 7 is your different views, your front, back, so on, those types of view. Control A is your normal to. F2 is to rename a feature, and Control S is to save your document. Okay, but these shortcuts you can actually go and customize it, right? So I'm going to go back. And how do we customize shortcuts or add our own shortcuts? We go here at Tools, and you'll see there's a Customize option here. Okay, and under Customize there's a keyboard. So here you can input all your shortcuts that you want to add. So you'll see you can filter it between different commands, edit commands, and so forth. Okay. All right, so that was it for the basic around SolidWorks, using SolidWorks. Now we're moving to sketching. All right, so sketching is obviously the sketch relation. So as you all know, if I look at a component like this, I'm just going to go here. I'm going to edit that sketch for me. There we go. Okay, so inside of my sketching environment, if I go ahead and draw a line. So Essentials 101 says that SolidWorks will automatically create automatic relations for us. You see that yellow icon there? That's an automatic relation that SolidWorks will put in. Okay, but let's say I don't want that on. I'm busy with my own sketch. I don't want SolidWorks to determine what my relations should be. So what you can do is you can hold in Control, and then it will actually remove the automatic relation for you. We'll see nothing pops up. It doesn't snap to any line. So yeah, it's quite useful to use. There we go. Sorry, I'm a bit in front now. Sorry, I'm just gonna the sketch relations one. Not bad. Sorry, the sketch relations one is to use a common vertex. So just to go back to that particular sketch, if I draw something like this, you don't have to go and select two of these entities and go and make them parallel. What you can do is you can select the vertex where the two lines meet. You can simply click on that vertex and make that perpendicular. So you don't have to multi-select two lines and then create a relation. You can just select the point where the two lines meet. Okay, sorry, I've mixed those two around. So we've discussed this now. Holding in control will just temporarily suppress the automatic relations. Okay, so the power trim or extend tool. So this is SolidWorks' Weed Eater. So this basically trims away unnecessary entities. You can use that to and also to actually do an extend of lines. So let me demonstrate this for you. So if I go back to this part and I go into my trim entities here, if I use my power trim, notice if I just click in my graphics area and I go over certain lines, okay, it trims away those lines. But let's say I've made a mistake now, I want to go back. Notice that square box there, it's either red or black. So if I hover over that black box again, it will actually reappear. That line that I removed will actually be back there for us. So we don't, if we made a mistake, we can do that. All right. Next thing is also using power trim is to extend the line. So for instance, I want to extend this line all the way through to that line. So what you can do is you simply click on that line, drag that line out. And wherever it meets, it will create a relation there for us. Click on that line, extend. Click on that line, extend. Click on that line and extend. You can make the line shorter as well. Click on that line, make it shorter. Click on that line and extend. All right. So that's my power trim. Dimension to tangency. All right. So this is where the shift key is quite useful. So if you're holding shift, let me demonstrate this for you. So I'm going to use my S key. I'm going to draw two circles. I'm going to make them equal. I'm going to make them horizontal as well. Now I'm going to go and dimension them. So remember, if I select two circles, it will automatically snap to the midpoints. All right. But I don't want this. I want to dimension the circles between the tangent edges, so meaning from that side of the circle to that side of the circle. So what you can do is you hold in shift, select that circle, select that edge of the circle, and now you can dimension it. Same goes with this side. So if I hold in shift, select that edge there and that tangent edge, and then type in 50. There we go. So that's how you dimension the tangency of edge. All right. Let's continue. Okay, the biap. This is also a great tool to use if you don't want to waste some time on using unnecessary geometry. So let me show you guys this. I'm just quickly going to draw a simple line like this. I'm just going to delete these. Okay. So how do I go and create an angle dimension between from the angle between this line and let's say a vertical line down? Okay. So usually what we would have done is create the center line on that point, go down, and then we use our smart dimension tool, go and create an angle dimension, for instance, like this. Agree. But however, there's an easier way. So what you can do is you don't have to draw this center line, this construction line. What you can do is you can select that line, select the endpoint, and there's a thing that pops up that's called a biad. So now you can choose the imaginary line that SolidWorks should create. If I click on that arrow, it creates that imaginary line. And I can type in my dimension. So you don't have to draw in that construction line. So this is also useful in drawing. So I'm going to show you an example of how I use this in a drawing. So if I zoom in a bit, using my S key again, remember that shortcut bar. I'm going to use Smart Dimension. So again, using the biad, I select that line, select that endpoint, select the biad point, basically imaginary line, and from here I can simply go and dimension it. Quick and easy. Okay, line to arc and back. So this is also Essentials 101. So if you create a line and you go back to the line end, it will automatically switch over to an arc. But I had a few customers that asked me, how do I switch back to a line? So I don't want the arc function. I want to have just the basic line function. What you can do is, let me show you this. So if I go, again, I'm going to use my S, my shortcuts, line. Okay, remember if I draw a line, go up, go back to that point, it creates an arc. Okay, that's quite easy. But let's say now, what happens if I go back to that point? It doesn't switch back to a line. So how do we change this? So simply, you just press A on your keyboard. Then it will switch back to a line. If I press A again, it jumps back to an arc. Right, this is an awesome feature. It's called the sketch on a model edge. It's just a time-saving thing that SolidWorks brought in. So what you can do is, if you select the inner part, if you select an edge and you select sketch, SolidWorks will automatically create a plane normal to that line and the closest endpoint. Okay, so let me demonstrate this for you. If I go ahead and take this component, I'm just going to open up this part. Okay. Let's say I want to go and create a profile. My idea is to go and create a sweep around these edges. All right. But first, I need to create a profile for my sweep. All right. So I'm simply going to click on that edge. All right. Then I'm going to go to Sketch, and I'm going to click Sketch. Okay. So what happened? The SolidWorks automatically created a plane normal to that line and that point. It's quite useful. So now you will see I am in an active sketch, and I can go and create my profile using S. Let's go and create. I'm going to create a silly profile like this, and now I can use that. Go to Features, and I'm going to sweep that profile all around my path, which is that one there. There we go. I can click OK. So it just saves you time to go ahead and go Feature Geometry, create a plane. Then you need to go and select the line, select the point, and then it creates a plane. And then you still need to go and select the plane to create a sketch on that. So this is a simple, quick, and easy way to create a sketch on a line. Okay, and lastly for the sketching is the function or the setting called the Enable Screen Input. Okay, so this is useful if you also want to save some time, but you must get used to it. So let me just demonstrate this for you. So it's a setting that you should put on inside of SolidWorks. So just before I put on that setting, so our usual interface is I go and click a line. From here, I need to go and dimension it like this. Okay, so it's a 3-step process. But if you put on the Enable Screen Input on Entity Creation, which is here, you go to Settings, Options, you go to Sketch. You'll see there's an option called Enable Screen Numeric Input on Entity Creation. If I put that on, and also create dimension only when value is entered. If I put that on, now if I do the same procedure now. I'm just simply going to create a line. If I go now, it's going to ask you to type in value, a dimension directly. Type in 180. Then you will notice it automatically created that dimension and the line for you with one step. So use it, don't use it, it's up to you. There we go. That's it for my part of the presentation. I'm going to hand it over now to Josh. So just bear with me. Josh. Make host.
Hi, can anybody hear me? Can you hear me?
Josh, I can hear you, yes.
My name is Josh, and I will be taking you through the next part of the video. Let me just get everything set up here in a moment. Put on my video. Can you all see me? If you can't see me, clap twice. Now I can't hear anything, so I think you all can see me. Let me put on my screen share. And there we go. Let's start out with the session. Oops, that is not what we want to see. Okay, guys, how's everybody doing today? That was really nice. Thank you, Rudolph. I'm going to talk through the parts and the assemblies. And let's just see, I just want to check one thing before we carry on. Okay, I'm going to chat through the parts and assemblies. And I'm going to start out with talking about 3D printing. So now a lot of the new manufacturing technologies are 3D printed, and it's becoming quite prominent even in the middle and lower class sections of the manufacturing. SOLIDWORKS introduced a new feature in 2020 called 3D printing. It's Print 3D. I've had a lot of guys ask me, what does it do and how can I use it? So it's a pretty new feature, and it's got some nice functionality for you when you're designing 3D print parts and printing it on your printers at home or at your offices or at your manufacturing plants. The Printer 3D is found in your file, and it has a searchable database of 3D printers. You can check 3D printer size, scale it, and then do other things as well. You can slice the data for 3MF exports, and the highest fidelity of SOLIDWORKS geometry is found in the 3MF export. If I'm going to show you an example, let's go over to that in SOLIDWORKS quickly. Just want to check if my camera is still on. No, yes, it is still on, so you guys can still see me. Okay, if I go over to SOLIDWORKS and we open up this part, we'll see that I'm done with this part now, and I want to 3D print this part. So I go File, I go Print 3D. Now this Print 3D setting is a new settings, and it asks me, I can choose my printer. I can go over here and I can go Manage Favorites. And I can select my printer from the selection of printers. If it's not there, you can make a custom printer yourself or select which printer you have. My particular printer that I selected has a 250 width and 110 depth and a height of 200 mils. Now I select the base of my model, which is here. And you'll see that the model is now placed in the zone of my 3D printer, and I can see how it fits. And I can also see if it sticks out of the model, if it's not in the right areas, if I need to rotate it. I can rotate it like this. I can move it around. I can orientate it automatically to fit. I can change which face is on the bottom, and I can scale it up, which the scaling function is quite nice. Now, once I'm done with that, I can also go and preview it. And the nice thing about this is when you're designing 3D parts, especially for FDM style 3D printing, which is the most common, is you'll have overhangs. If I turn on this face, show faces that require supports, and I have a threshold of 45 degrees, you'll see that anywhere that is or more than 45 degrees will be showing in red. Now, what's nice about this, and previously, you would have to export the part to your external program, slice it, and you'll see, okay, and you have to look, okay, that's where I'm going to do it. Now you can see it while you're designing your part and say, okay, I'm going to change this now. So I go over here and I'm going to change this back to, I'm going to make this into a chamfer, for example, over here. Let's make it 12. And then I'm going to go File, Print 3D. Okay, and I'm going to go back to where I was earlier. And now we will see that on the settings, it is now not showing red anymore. Further down, you can also set the layer height. So I want the layer height at 0.2 and I can slice it. And now I can see the striation lines that are going to form, and that can help me in my design process while designing the model. Further down, I can set which material I'm going to be using for the thickness and gap analysis, and it will suggest a thickness of wall that is most optimal when printing this. Once I'm done, I go to my settings, I go down, I press down over here at the Save to File, and I can save it out in 3 different file formats and import it or export it to my specific external program. Okay, next up, we're going to talk about when you're working with parts. Usually a lot of guys are working with imported parts. Now, imported parts are not SolidWorks parts, so they're not native to the SolidWorks interface and the SolidWorks features. So what do you do when you work with an imported part? I've noticed a lot of clients that I work with don't do import diagnostics as they import their part. Why would you do import diagnostics? If you don't, import problems prevent conversions into valid solids. So later down the line, when you're trying to convert this into a solid or save it out into a different file type, or convert it or edit it or insert it into your assembly, it may give issues. So you don't know why we do that. So now we have to fix it. This wizard will be the first step whenever you import an imported part. It will attempt to repair faulty faces and any gaps that it finds. Keep in mind, I'm going to show you an example of a part that I made in SolidWorks itself. And I saved out as a neutral step file or neutral IGES file. Step file is also fine. And I re-imported it directly back into SolidWorks, and it still gave a problem. Why does this happen? Because there is a translation process that happens between the mathematics between different types of file types. Now, this conversion process is not perfect, and will obviously introduce errors as it tries to recreate it in the different file types so the different systems can read it. Give you an example, I go to SolidWorks. I'm just going to close the last thing I was working with. And I'm going to import a external file that is not a SolidWorks file. Okay, this file was actually made with SolidWorks. You can see it was originally a SolidWorks file. I saved it as an IGES file and imported it, and now is it an imported body. If I go to my Evaluate tab and I go to Import Diagnostics, you will see that there is one face that is faulty. Now, even though this was a SolidWorks part, I still got to repair it. And I click Attempt to Heal All, and this tool now works and attempts and heals it all. Keep in mind, sometimes this tool does not work, and there's a whole process that you must follow, which you can find on the SolidWorks help to carry on with the fixing process. And it's always recommended to always fix most of your errors. Well, it depends on what you're going to do with the model, but if you're going to modify it, then fix your errors before you carry on. Okay, so now I have my imported part. How do I edit it? What do I do? What are the options? Well, 2 of the options I'm going to give you, 2 tips that you can do is you have feature recognition, which is this really powerful tool with a built-in SolidWorks called from FeatureWorks. These used to be only for, in the older days, used to be only for high-end packages and for the most advanced premium packages. But now it's in all the 3D packages from standard to premium. You can do this in one shot when you import the part. As you saw earlier, it will ask me, do you want to recognize the feature? If that is turned off, then you can do it by hand, going to your Insert and Insert FeatureWorks. You can also interactively do it, which I'm going to show you now as soon as you do a demo with it. I don't think a lot of you guys know that you can do that. But what happens if I don't want to do FeatureWorks? I want to just edit the model as it is like that. Well, you can also use things like split, and you can split the bodies into multiple pieces, move them around and extrude pieces along. You can use the move copy body to move them as wherever you like. And then you can use normal features to fill them out or fix the gaps in sketching functions. I'm going to give you an example of that quickly. So on my same part over here, if I want to go to FeatureWorks, I can go Insert. And I can go down to FeatureWorks over here and so recognize features. But now say I want to just recognize this hole and I want to edit this hole. Interesting, it can work on any other hole or any fillet. I press on this hole and I press Edit Feature. It'll automatically run FeatureWorks on that hole alone and put in my feature tree as if I just added there. I can now delete this feature or change the sizing as I like, and as if it was a SOLIDWORKS feature. This will work as well if I do it over here on this fillet and I go Edit Feature. You'll see that now I can change the sizing of this feature like it's a part and it's added to my feature tree. Keep in mind though that this interactiveness will not work all the time. So example, this one, I go Edit Feature. It's going to fail because it doesn't know how to do this as a single feature. It needs to follow a step process with the full recognized features or other features before that to get to this feature. Okay, but now say I don't want to do this. I don't want feature recognition. I want to edit the model directly. Okay, we can do that. And there's a really nice tab for this. And I don't know if a lot of guys know this. You can right click on this tab and you can go Direct Editing. The Direct Editing tab is all the functions you need, well, most of them, which you need to edit something directly, very simply. Cut it apart, extend it, move it around, delete faces. So I'm going to use that tab. So firstly, what I'm going to do is I'm going to make a copy of my front top plane with the control trick. Just pull it out, drag it to about there. And I'm going to set it over here to 55 millimeters. I'm going to press OK, and I'm going to go Direct Edit, and I'm going to go Split. And I'm going to cut this part in 2 parts with the reference plane. Okay, once it's cut into 2 parts, then I can select which parts I want, and I'm going to say OK. I can now hide this face, or that plane, and I can use my Move Body. Select this body, I'm going to move it out. Doesn't matter how far you can move it, you can set it in the Property Manager. And press OK. I can now press over here and sketch directly onto there. I'm going to use my Convert Entities and go Features, Extruded Boss Base, and I'm going to extrude it up to my next. Now you'll see I've successfully modified this part to what I wanted and made it a bit longer without actually having features in the tree to work with. Quite a handy little tool. I see my video, is my video still on? Yeah, sorry. Okay, re-import imported part. So a lot of the time when you import a part to SOLIDWORKS that is imported or not native to SOLIDWORKS, it'll usually come in a weird sort of orientation. It's not really flat to your front plane and your right plane. The coordinate on the origin and your origin is like completely far apart. So how do you fix this? You've got to create a new coordinate system, and then you can save this out as the same file type in referencing the new coordinate system. How do I do that? So I'm going to show you now quickly. I'm going to go back to SOLIDWORKS, close what I was working with, and I'm going to import another file, which is an IGES file. And you will see that the origin is sort of way off at the bottom here. And if I look at it straight on, the front is not what I want. I want it normal to this face. And the right is also not right. I want it completely flat on this, with this face flat, or this edge flat. horizontal or vertical, sorry, vertical. How do I fix that? What I'm going to do is I'm going to select this face and go sketch on that face. I'm going to go center line. I'm going to draw a center line across. That'll be my first direction. And I'm going to draw another center line from the top here down to the middle. Now I'm just going to rotate this model so you can see where the center is over here. That's where my coordinate system is. And this line is going to be my x-axis and this line is going to be my y-axis. What do I do now? I exit sketch mode and I go features and I go reference geometry, coordinate system. Okay, now I select a center point. That is my center point. And now I can select my x-axis and I can select my y-axis. You will see that where the arrow is pointing is the positive. I want my y to point up, so I can flip it over here. But I also want my z to point the opposite way, so I can flip my x. Now I'm happy with it. And I press OK. You can see my new coordinate system in the middle there. Now what do? I go File, Save As, and not as a part file. I'm actually going to save this out again as an IGES file. And you could select the options. And you'll see there's an output coordinate system. If you press that down, you'll see my new coordinate system is there. I press OK. And I'm going to resave this as updated. Now, if I open up that new file, I'm not going to save this one. I'm going to open up my new one. And we check now where my origin is. Oh, look, there it is where I put my coordinate system. If we go to the front face, the side views, it's all exactly how I want it to be shown. Nice little method for fixing the orientation, and now you can insert it to an assembly without worrying about it being strange directions and strange planes that you want to match or mate. Okay, well, that's enough for the parts, imported parts. I'm going to talk more about another topic, in context assembly design. A lot of guys know this, but a lot of guys have no clue how to use it. Now, why would you use something like this? What is in context? You would make parts in context of your other parts in your assembly. Why is this useful? Say I'm making something that only can be designed to the other specifications of the other parts in my assembly. Now, I know when I was learning SOLIDWORKS, what I used to do is I used to go to my assembly, put everything together, measure it, switch over to my part, draw it out, switch it back, measure it again, draw it out, extrude it, throw it into my assembly, go back, edit it. And it was just a really long process to make something. And now I realized it didn't work, so I changed everything. In context is so much easier, and you can make the parts directly in your assembly there, edit them and change the sizing, and then save them out as their own parts. Okay, they automatically update to any parts that they reference. Existing parts can be easily edited and changed. The new parts can be created inside the assembly, and it saves you so much time. Let me show you an example. I'm going to switch back to SOLIDWORKS, and I'm going to open up this vise I have over here. This vise has a face over here and a face over here, and I want a plate that I want to move along this edge or this face to this side, and I need to make both those plates in context of the sizing over here. Show you an example. I'm going to go to my assembly tab, and where you find insert, if you press down, you'll see that there's a new part option. Press new part. You'll see that there's no options in any of my tabs now. Okay, but next to my mouse I have a little check mark. It's asking me to select a face where I'm going to start sketching onto. And I press here. Now I'm in sketch mode. I'm going to select this face again, so this face, and I'm going to convert the entities of this face. Ooh, okay, wait 1 second before I do that. Just roll it back because that's for just now. I'll show you guys just now. There's a button over here. I'm going to select this face and convert entities. Now this has reference back to those edges. Okay, I also want this circle over here, and I convert the entities over there. I go features, extruded boss base, and I extrude this out 5 millimeters. and I press OK. You'll see I'm in a complete in-context edit mode. I have all the options as if I was building this part. If I press edit component again, I exit that, and you'll see the part is now entered and fixed in place in my model. You'll see it is even in my design tree, and it's got its own name, part 4, and it's related to the vice. If I expand this, you'll see that there's a little arrow by the boss feature, and below that I'll expand it as a sketch. This little arrow is pointing, saying that it has relation to something. What does that mean? It is related to the piece that I initially selected, the face I initially selected it on. So if I change this edge, so if I change this fillet, for example, on the fly here, I'm going to change this fillet to 5 millimeters. And I'm going to press Control Q and update the entire model. You'll see now it completely updated. And that's a pretty cool feature right there. How does it hold it in place? Because now I can't drag it. Oh, okay, I'm not supposed to be able to drag it. That didn't work. It was obviously because I pressed the references. I'll show you that in a moment. Well, at the moment, you'll see that now it obviously moves around. But if I press Control Q again, it's going to jump back. Keep that in mind when you're building with your model and you do these in context and you move it around and you're like, oh shit, I press Control Q and it goes back and I'm like, oh, what is it doing now? Why is it there? And I move it there and I move it there. I press Control Q. But keep in mind, if I try look at this in context model and I check the origin, if I press on the origin, you'll see that the origin is somewhere sort of in the middle of nowhere. I don't even know where that is. And that happens because now it's moving around, but we need to relate it to the model somehow. So what I'm going to do, I can add mates just as I add any other mates. I can go mate here. I'm going to use an advanced mate. A path mate, I'm going to make this corner onto this edge. First of all, then I'm going to use 2 standard mates, a parallel mate between this top face, and this front face and this face. Ooh, that second one must actually be a parallel. There we go. Now the model will move how I was intended to, well, how I intended it to. Okay, well, that's how you start an in-context design. But now I mentioned all these references and external references. What are these doing? And you'll notice when you're designing, there's a lot of arrows pointing around and references are broken and it's very annoying. So how do you work with them? What do they mean? Well, when you're making that model, you noticed earlier I had this button on because I was testing this earlier. There's no external references option. When that is on, it doesn't make an in-place mate. I'll show you what in-place mate in a moment is, and no external references are actually created back to it. The part is completely on its own, but it's still in context of the assembly. So what do we call them? We call them virtual parts. They're actually inside of our assemblies. I'm going to talk about that a little more in our next slide. But what happens if I want external options, but now I've got a bunch of them and I want to control my external references? So I can actually lock and unlock these references. If I lock the reference, that in context part will stay the same and I can modify everything around it, even the parts that are actually referencing or referenced by that part. Nothing will change. If I choose to completely break these external references, then the part will not update and it cannot be restored again. So this reference can never be restored. This part is completely on its own. Give you an example quickly. I go back to my model that I was working on. If I make another plate on this side, I go with the same procedure and I go here and I say new part. And I select this face now to sketch on. You'll see that that option, no external references, was on. Now, if I press that on and I do the same as I did earlier, and I press this face and I convert it, you're going to see that it actually makes an underdefined sketch, but it's exactly on the edge there. I can go features, extruded boss base, and extrude this out 5 millimeters. Now exit the components. What happened with this? It still gets given an in place over here, but it does not have reference back to the original model. Let's make sure about this by scrolling to the part and looking at the boss extruder, which doesn't have a external references mark. Show you another example. If I edit this fillet over here to 3 millimeters and I update it, The part I made in context will not update. Okay, but I still won't move. I need it. If I want to move it, that in place is holding it in place right there. If I right click and suppress that in place mate, now I can move it around. I suggest suppressing it rather than deleting it because it was the original way that it was made in this model. Now, if I unsuppress it, it'll go back there. If I right click and edit the model and open it, I can edit it like a normal part, like a separate part, but it's still actually in my assembly. It's not a separate part on its own, but it just does not have reference to the part it was made. I can now add in dimensions and change the sizing as I like. Okay, but what happens if I now want to actually make a separate part? If I want to make a sort of a library feature, or I want to make a part that I'm going to throw into my database and use it in other parts, well, you can do that. You first start out with external virtual files, which are saved internally in the assembly, as I've mentioned before. You could also make an external file, which has its own part or assembly file. Keep in mind that this can be also even sub-assemblies inside of your assembly that can be built. Okay, what are the pros and cons of that? Virtual components can stay inside of your assembly because it makes everything central, and you won't have problems with parts being not found or missing around your computer because references are broken to external files. This you'll find if you try and move the top level assembly without the rest of the parts or not using pack and go. But at the same time, it makes your assembly very large because everything will be inside of your assembly. If you want to save it out, you can use this tool called Save Part in External File. I always suggest renaming the component first and then right-clicking on the virtual component and clicking Select Part and Save Part in External File. If I go back to SOLIDWORKS and I show you an example, I'm going to save out this file we made previously to a separate file. I'm going to right-click on it, or actually now I'm going to press on it, press F2 or double-click slowly, and I'm going to rename it Plate. Now I'm going to right-click on there and say Save Part in External File. Get the option to save it as in the same file as this assembly. Specify where you're going to save it, internal to the assembly or the original path. I'm going to save it where this assembly is, and I'm going to press OK. Now it's saved out. You see it renamed it. I can right-click and open it. You'll notice that the references are still there. There's still references back to the other part. But now, if I look in my file, in my documents, and I go into my documents over here, you'll see that there is a new part. There is a new part called Plate. There's a separate part file on its own. Why does it still have external references? That's because they are still referenced back and I haven't broken the external references. I can do this by going onto the part itself and right-clicking, either the part itself or the top level to see all of them, and going all the way down to external references, which I cannot see at the moment. I can get the top level here. External references. And you'll see that the plate has an in-context external reference, and the sketch is the one that has the external reference. So I can isolate this part. Okay, and I can lock or break them. If I lock them, and I press OK, and close this, even though it still has a reference, you'll see the little star is shown now. That means it's locked. And I double click on this and I edit this. And I say rebuild. It's not going to update my part, but it still has a reference back to that. Okay. And yeah, that brings me to the end of my section. It's been about an hour now. I'm going to hand it back over to Rudolf. I'm going to end the slideshow over here. And I'm going to hand it back to Rudolf. Just hang in for a second.
There we go. Okay, thank you, Josh. Thank you for your presentation. So finally, this is just to conclude here. We've just have a Q&A. So if you guys have any questions for me, for Josh, or for Quentin, please put it in your chat window. If you have any other queries, you can reach us at support@mecat.co.za. Yeah, like Quentin said in the beginning, this presentation will be shared to you guys. So please feel free to get in contact with us. Thank you so much, guys, for joining. Yeah. I've got a question here from Team Cliff. It's yes, okay. Open up. Let me just see everyone. Team Cliff. Cliff, you said, is it possible to create planes using an up orientation to control their normal to viewpoint? That's a good question. I remember you posed this question to me a few weeks back. To be honest, I think I know what you mean. Let me just get SolidWorks here on me. So as soon as you create a plane, for instance, I'm gonna go and create a front plane like this. Okay, notice the arrow. So currently that arrow is showing down, so that's like a down plane. If I click on that plane, and I create that plane. So if I go normal to that plane, you will see it takes me normal to. So if I click on that one again, normal to again, that's the positive and the negative of the plane. So that's your up and down. So if you want to switch that plane around, if you want to switch the up and the down position, you can simply click on that plane, and you can use flip normal. Then the up will be down and the down will be up. I think that's what you meant. Is there more you need from that? Let's see here. Thank you, Dale. Appreciate the comment. Thank you, Stephen. Cliff, you said that if you want to turn it 90 degrees, or do you want to turn the plane 90 degrees? I'm not. So you want to turn the plane 90 degrees or the up 90 degrees? The normal to view 90 degrees. Why don't you just create another plane then, rather than use the top plane? That's what's 90 degrees, or am I mistaken now? Like that. Shift and arrow up. That changed the view. Quentin, I think I can mute you as well. Then you can also jump in here. Let me just see here. Unmute Quentin Berger.
Yeah, thanks. I think it gets quite tricky to get questions. What I think, let's maybe email us directly, guys, at support@mecat, and then we can do a Zoom session with each of you if you have specific questions. We're all working like this now, and we're all getting used to using this technology. So engage with us, contact us, and then we can be in touch with all of you individually. So I think maybe, Rudolf, let's wrap it up. And thank you, everybody, for attending. And please look out and keep in touch and connect with us. Keep safe, guys. Have a great weekend.
Cool. Thank you, guys. Yeah, just post those questions you guys still have with via email. You can email me personally or just support. Thank you, guys. Have a good day.